Now let us continue to look at almost sure convergence. So I would actually like to repeat once more the point that I was making in the previous video. So when we look at almost sure convergence, then we say that xn tends almost surely towards x if the probability of xn going towards x is 1. And what we mean more specifically by that is if the set of omegas on which xn tends towards x has full probability 1. And what we mean even more specifically is that if we consider our probability space, and yes, I am actually going to repeat what I said before again, because I think this is a very important point. If we look at the probability space and we consider an omega, then this omega is mapped by x1 into the value x1 of omega. It's mapped by x2 into the value x2 of omega. And we ask ourselves the question, considering x3 of omega, x4 of omega, and so on, can we then say something about how this behaves, as in goes towards infinity? Does it converge towards something or doesn't it? And if it converges towards something, then we call that something the limit of xn of omega, and we may call it x of omega, for example. If it doesn't converge towards anything, well then just bad luck. So if we consider the set of all the omegas where xn evaluated in that omega converges towards something for n going to infinity, so if there are omegas all around here in this probability space, then let's say that these are all the omegas for which, if we evaluate xn in each of these omegas, then xn will tend towards a stochastic variable x. And there are these other omegas where it doesn't go towards x. Now, where it doesn't go towards anything. So if we look at this set, the question is the probability of this set equal to 1 or not equal to 1? If the probability of this set is equal to 1, then we say xn tends almost surely towards some limit, which we call x. If it isn't equal to 1, well, then we can't be almost sure that xn tends towards some limit, because then there's a substantial set of omegas for which xn does not tend toward anything. So this is the concept of almost sure convergence. However, when we do this, we are implicitly assuming that the set of omegas on which xn of omega tends towards some limit x of omega, we're assuming that this is measurable. What I mean by this is we're assuming that this set is an element in our sigma algebra F. But is it actually true that this set is measurable? We can think a little bit about that, because it's not a given that this set is measurable. I won't talk about that now, but I think it is something that you should think a little bit about, and eventually probably look a bit at your lecture notes and try to see if that's something that Ernst has spoken about during lecture. So if he has as well, look through that proof. It's a very good idea to look through that proof. So I will talk about this part in a video later on, but just think a little bit about that. Now, let me just delete what I just wrote here, and in the next video we will start solving this exercise.